Hello, this is Dr. Dinakaran M, Associate Professor, Department of IT, School of Information Technology and Engineering, VIT University, South India. I'm just going to present a session on OSI layers. Before getting into OSI layers, I'm going to give an idea about what is networks. Network is a group or collection of nodes which all these nodes can able to share resources. What is a node? Node is a kind of device. It is any device which is capable of sending or receiving or both. For example, some devices like TV, radio can able to only receive signals, whereas some devices can able to only send signals. Some devices like smartphones, computers can able to send as well as receive signals. So node is a any device which can able to send as well as receive, or sometimes only send or only receive. Now, what sort of resources can be shared using networks? Resources can be like data. For example, I just wanted to share some official information to some of my friends who is sitting in different location. So I'm sending the data through network, and we can able to share devices like printers, scanners within the networks. Sometimes some networked applications we can share. Sometimes a common service will help you to share, say, web servers, websites, email access, all those steps. And we can also able to share resources of additional hardwares. So a overall view of network is, it is a group of nodes which can able to share resources. Next, we'll see what is OSI layers. Now, OSI layer is abbreviated as Open System Interconnection, and it is a standard model from International Standard Organization ISO. It is derived by ISO, and it is it is a layered communication level architecture specified by ISO. Now, let's take an analogy to understand what is layered architecture. The analogy which I am going to explain you is car manufacturing company, or how car is manufactured. To manufacture a car, there are set of procedures wherein which we have to start with stamping, then welding, then painting, then assembly, and then final inspection. Let's see step by step. Now, when you go for manufacturing a car, first step is the metals are taken from various industries, and stamping is based on stamping is created for creating various parts of car. For example, door beam, and a pillar reinforcements, side member reinforcement, front bumper. Now, based on the parts of the car, the stamping is done with the metals, and then the stamped metals are welded to create the basic body of the car. And then the body which is created through welding will be moving to painting, and there the robots will paint the car body. Then the car body will be moving to assembly section, wherein which the assembly section will assemble various units of car. For example, engine, gearbox, seats, wheel bases, wheels. All those various parts of cars are assembled in assembly area. Now this is the major area wherein which the car is getting ready, and then the car will be moving to inspection area. So in inspection area, the quality of car is as per the standard, it is verified by the people. Now the analogy of car manufacturing says that there is a layered architecture when you manufacture a car. The first step is stamping, and then welding, and then painting, and then body assembly, and the inspection. At the end, the product is ready to move. Now, from the analogy of layered architecture, what we are learning, it is a 5-layer model when you see car manufacturing, stamping. Let's see step by step. Now, when you go for manufacturing a car, first step is the metals are taken from various industries, and stamping is based on stamping is created for creating various parts of car. For example, door beam and a pillar reinforcements, side member reinforcement, front bumper. Now, based on the parts of the car, the stamping is done with the metals, and then the stamped metals are welded to create the basic body of the car, and then the body which is created through welding will be moving to painting, and there the robots will paint the car body. Then the car body will be moving to assembly section, wherein which the assembly section will assemble various units of car, for example engine, gearbox, seats, wheel bases, wheels. All those various parts of cars are assembled in assembly area. Now this is the major area wherein which the car is getting ready, and then the car will be moving to inspection area. So in inspection area, the quality of car is as per the standard, it is verified by the people. Now the analogy of car manufacturing says that there is a layered architecture when you manufacture a car. The first step is stamping, and then welding, and then painting, and then body assembly, and the inspection. At the end, the product is ready to move. Now from the analogy, what we are learning, from our car manufacturing analogy, what we are learning, let's have a small analysis. Now car manufacturing is a 5-layer model where in which similar types of tasks are grouped together, which we call as a layer. So all similar type of tasks are grouped together to form a layer, and this tasks are completed one by one in a proper order, which we call it as layered structure, and there will be a proper interfaces between all the layers, and end of all layers task, the product is ready. Now that is how we are learning what is layered structure. So when there is a ultimate product is a output, before the output we have a layered flow. One by one we are implementing it. For example, in our analogy, first we go for stamping, then we are welding, then we are painting, and then assembly, at last inspection. At the end of inspection, the product is ready. That is how layered structure works. Let's see how layered structure in networks, which is OSI, is all about. Now it is a complete architecture of networks in a simplified model. When there is a network is structured, now with reference to OSI layer only, the flow of the data is formed. Now this layered structure, which is OSI layer, helps in creating or controlling set of protocols, and then it controls the network elements, and then it helps in managing the network properly, and then if there is any problem in the network, to troubleshoot or debug the problem, this structure or layered architecture helps us. Layers in OSI. So I'm just going to explain OSI layers considering there is a data travel. So in that view, always the data will be starting from the end user, say source. So when you act as a source, the first layer comes in picture is application layer, and then presentation layer, and then session layer, and then transport layer, then network layer, data link layer, finally physical layer. When you refer OSI layers in general, people used to say First layer is physical layer, then data link, then network, then transport, session, presentation, and application. Actually, my personal opinion is, so when the data starts from the end user, that is the origination point. So usually the layer which receives the data first is application layer. So the flow goes like application, presentation, session, transport, network, data link, physical. So the data will be received by application layer from the end user, and it will be sent by the physical layer as a signal. So various processes are involved between application and physical layer. So ultimately application layer is going to be the starting point and as a ending point for a data travel. Assume that you are sending a message to your friend through Facebook chat. So the layer which gets the data when you type as a hi message from you is the application layer, and it's the application layer at the same time which will deliver the hi message sent by you to your friend. So the rest of the layers including application layer will work in between what is happening, like in between from hi message from you to the end user, your friend. So let's analyze step by step how individual layers are helping in transferring your hi message from one end to other end. So let's see the OSI layer tasks. The first layer is application layer. The duty of application layer is to interact with the end user or application. Okay, end user can be sometimes a user or it can be a program. So what is the part of application layer is, it's a kind of a person who is sitting in a bank and interact with the clients like as a cashier. So the application layer, whenever there is a message to be transferred towards some destination, application layer is the interface which actually receives the data from the application layer. So it receives the data as well as it delivers the data to the end user. So always when there is a data travel from one end to other end, the only layer which interacts with the end user or end program directly is application layer. Then the next layer comes is presentation layer. Now you are ready to your data is ready to travel. When your data is ready to travel, the application layer has received the data. The first step is over, and the next step is the next layer, presentation layer, decides on how the data should be formatted. Formatting in the sense, for example, you are sending a message on a particular format, say image can be in of JPEG format, in IMG format, or it can be PNG format, or it can be of any format. So now the data formatting part of presentation layer takes care of converting the data into a specific format which can easily travel through network. So that is taken care by presentation layer. Apart from that, presentation layer concentrates on encryption of data. Encryption in the sense what? Encryption is the process of converting the data from readable format to unreadable format. For example, you are talking with your friend who is in a public. Okay, you both are in a public. You wanted to convey some message to your friend, but you wanted to convey this message as a in a secret way. What you can do, you can either talk in a personal language which is only known to you and your friend, or you can pass through some signals. So first example what I told is, you can talk in a way which you and your friend can understand. So that is called as encryption. You are converting the data from readable format to unreadable format. When the data is encrypted, the unreadable format will travel. Ultimately the public will not be able to read your message. So at the end, when it goes to the end user, the encrypted data will be decrypted, which is from unreadable format to readable format. And the next task by presentation layer is compressing of data. Depends upon the size of the data, depends upon the requirement of network. The data can also be compressed and decompressed for a safer data travel. So that's all the duty of presentation layer. Next comes session layer. The session layer is going to take care of establishing sessions between the ends. It takes care of synchronization between the ends. I can explain you the process of session in a two examples. The first example is, assume that you are logged into your say mail account or a banking account. Say you are doing some transactions for some 2-3 minutes, and you are moving out from your browser, and you are taking care of some other tasks. Say after some 10 minutes you are coming back and trying to access your banking page. When you access your banking page, what happens? You are getting an error that your session is out. This is one example. And the other example is, assume that you are talking with some of your friends through web chat. I mean, you are chatting, not talking. When you are chatting with your friend, say after few minutes, your friend is a friend's node is disconnected from internet. What happens? You are getting offline message. Okay, and say after few minutes your friend got connected, and ultimately what you are getting back? Online message. So with these two examples, I'll try to explain you what is session is all about. Session is a timing given for a connection between two applications when you go for a data travel. So it is a timing. Okay, for example, when you log into your banking website, if you are inactive for say 2-3 minutes, automatically your session will be closed. It is a normal session. For example, you are going for a meeting, the session time given for the meeting is say 1 hour, as simple as that. So session is the timing between the data travel nodes, I mean end to end. So that is about session layer. Session layer takes care of this synchronization between nodes in terms of sessions. And next is transport layer. Transport layer ensures the end-to-end connection is made. What is end-to-end connection? End-to-end connection is it is all about from the data. Say for example, you are, again we'll go to the previous example. Say you are sending a message, hi message from Facebook chat, from your node to your friend's account, the same Facebook chat of your friend's account. So now when you are connected with network, it's not that you're running with only one particular browser and with only Facebook. You may have multiple processes running in your system. You can, at the same time, you can browse through your banking website. At the same time, you can play games. Some pop-ups will be there for you to give a cricket updates. Various process will be running which is connected with internet. Now the duty of transport layer is to ensure that a proper end-to-end connection between your Facebook chat and your friend's Facebook chat. So that is process to process communication is going to be taken care by transport layer. Apart from this, transport layer has some more should be done, some more tasks it carries. I'll explain you in a detailed way about transport layer within a few minutes. Let's network layer. Network layer takes care of addressing of a node and routing of a node. I mean routing of a data. For example, say you are sending a message from node 1 to node n, which is staying in different location. So addressing helps in identifying the individual nodes. Routing takes care of routing the data towards the destination. Why do we need routing? Routing is needed when you have multiple options to travel. So you should have a right route to travel. So that process will be taken care by network layer. Now I just wanted to go for a recap of the last three layers, which is session layer, transport layer, network layer, with the addressing point of view, because this is the important part which we will make us to understand how addressing really works when there is a data travel between nodes. Let's take another analogy. Assume that you are sending a letter to your friend, okay, and your friend stays in some apartments, okay. Say you are sending a letter to your friend who is staying in Chennai, and apartments is there in say T Nagar, okay. In T Nagar, say Sugumar apartments, and in Sugumar apartments you have say some um, 4 5 blocks, say A block, B block, C block, D block, E block, and each block has at least say 6 homes. Now the addressing for your friend's home is what? Say your friend name, which home number, and then which block your friend belongs to, and then which apartment your friend belongs to, and the hierarchy is goes on like this, okay. So when you take an address, it's not that directly you're connecting to the destination, I mean your friend. There is a proper hierarchy: apartments, in apartments which block, in the block which home. This is the hierarchy when you take a typical addressing mechanism. Let's compare the same with the data travel when you are moving towards from one node to other node. Assume that you are sending a message, again Facebook message, from your node to your friend's node. You may be sitting in India and your friend may be sitting in Singapore. Now how we can identify the system which is having the Facebook chat of your friend's account? There is a process, right? So what happens? The network layer takes care of identifying the source node and the destination node, source network and the destination network. So it just identifies the network as well as node with the help of IP address. So what happens? It's a process of say identifying which apartments your friend belongs to. So we can compare this apartment with the network layer addressing of networks and nodes. So IP address identifies from which node the message is traveling to, from which network the message is traveling to which network and to which node. Now that is the role of network layer when you talk about addressing. And in between, network layer also takes care of routing between various available intermediate nodes and various available intermediate networks. So network layer identifies through which route it has to, I mean your message has to travel, like a say a postal service or a courier service. Next comes transport layer. So when it comes to addressing, what transport layer does? Transport layer actually identifies a process which is running in your computer. So again, when it comes to analogy, there is a apartment in that which block your friend homes belongs to. So transport layer works in that way. When you have a computer which is running with multiple process, one for Facebook chat, one for cricket update pop-up, one for banking website, one for some gaming application, one for some updates for some softwares. When various applications are connected with network to get internet connection, the right process, source process or destination process, say which is Facebook chat, Facebook page, should be identified. So that process is taken care by transport layer, and again that is the addressing, where in which transport layer uses a special numbering called as port numbering to identify the individual process in a node. So with the addressing mechanism using network layer, we have identified source node and destination node. We have identified in the node which process is triggering the data or which process is getting the data. And next comes session layer. Now what session layer does? Within a process, we are in which session. For example, let's go back to the previous analogy of session layer example. Session layer, what we analyzed two scenarios. One, you are accessing your banking web page, and the other one, you are talking with your you are chatting with your friend through chatting application. So Session layer ensures that your connection between process is live or not. Okay, for example, you established a connection through Facebook chat. Assume that you are disconnected. What happens? You are not connected. You are not connected to the internet. Automatically your synchronization between your Facebook chat is out. Okay, or you are not active for a banking website for say last 15 minutes. Your synchronization between the banking website server and you is out. So ultimately, session layer using session ID, it takes care of identifying the current synchronization status, current dialog status between the session of the source and destination process. So when you relate these three layers in terms of addressing, you can able to understand the concept of these three layers very easily in terms of again addressing. So network layer identifies the process, network layer identifies the network and the node, and transport layer identifies the process within the node, and session layer identifies the session within the process. So it goes on. When you go from the source point of view, session to process, process to node, node to network. When you look into destination point of view, network to node, node to process, process to session. So that's how it works. So I hope you got about this three layers, the relationship between these three layers. Next we'll move on to data link layer. So data link layer is the layer which has a proper control on the reliable media between two nodes. It is the layer which keeps track of what network technology is there, underlying network technology is there, which is physically taking the data towards the destination or physically transferring the data between the nodes. So data link layer has a proper control on the medias. For example, you are connected with say one of the Ethernet technology, at the same time you are connected with say one of the wireless technology, say GSM, and data link layer has a control on it for which technology what type of data has to be traveled. For example, see, wireless technologies will have signals in a particular format. Wired technology, say Ethernet, will have a signals in a particular format. So depends upon the network technology, the signal format changes. Depends upon the signal format, your data format should change. So all this, you know formatting or kind of framing stuff will be taken care by data link layer. So data link layer will convert the data into a special key called as framing, which is which is suitable to the underlying media or underlying network technology. Next comes physical layer. Physical layer is the layer which is actual which is maintaining actual relationship or connection with the media. So whatever we do on the top layers will be converted as a binary by the physical layer, and finally the binary will be converted as a signals by the physical layer, and it will be accessed sent through media, cables or wireless adapters. The signals will be traveling towards the destination, which will be taken care by physical layer. So I'll just summarize the tasks of application layer, tasks of OSI layers. Application layer interacts with the end user. Presentation layer takes care of, after receiving the data from application layer, presentation layer will take care of the received data format. Again, it takes care of encryption and compression format, compression methodologies. And session layer controls the session between, or it takes care of synchronization of sessions between nodes. And transport layer ensures the end-to-end connectivity by identifying the process using port numbers. And network layer takes care of proper addressing of nodes and networks. At the same time, it takes care of routing between nodes, and then data link layer takes care of controlling the media between the nodes, and physical layer actually gets the framed data from data link layer and converts into binary, and from binary to signals, and signals will ultimately go through the media. Now let's take how things happens in the source. Okay, assume that you are having a data, hi message from Facebook to your friend. What happens? The data is ready to travel. Now who will interact with the end user to receive the data? It's the application layer which receives the data from end user. And what happens? Now application layer will add a control information called as application header. Every layer, though it is a structure, every layer will add some control information with the original data. What this control information all about? This control information helps in smooth data travel from one end to other end. Okay, now let's see, for example, let's take session layer. What happens in session layer? Session layer will make use of session ID to maintain synchronization between the between the sessions. So we have to add some session ID. Okay, similarly, when you take transport layer identifies the process. We have to add the process number. So like that, every layer will have control information to add. So similar, in that way, application layer takes the data and adds the application header. Further, the data will travel to presentation layer. Now when the data moves to the presentation layer, the application layer is not at all a special header to the presentation layer. For presentation layer, the data is original data plus application header. It will never bother about what is the application layer header at all. It is a typical data for presentation layer. Now what presentation layer does? Presentation layer adds its own header. What could be the header for presentation layer? The presentation layer header can be a control information about what? About the data formatting, the data encryption, and the data compression. Further, the data will go to the session layer. Again, you can watch session layer. For, the data received from the presentation layer will never worry about the presentation layer's header. Now further, the session header is added. Session header will have the information about session ID to identify the session status, and then the data will move to the transport layer. Now transport layer will add the content of process number and some more information for successful data transfer, for a reliable delivery of data. When we look about transport layer, we'll analyze more about transport layer header. Further, the network layer, the data will move to network layer. Network layer will add its own header, and then the data will move to the data link layer. Data link layer is the only layer which will add header as well as trailer. Data link layer uses the trailer to identify the errors between the neighbors. Between the data will travel from one node to other node, right? It's not that you are sending the data from source to destination directly. When you send a data from source to destination, for example, your source is A and your destination is E. So the data will travel from A to B, B to C, C to D, D to E. Now source is A, destination is E. Intermediate nodes are what? B, C, D. 3 intermediate nodes. Now when the data moves from A to B, there could be a possibilities of creating errors in data. What is error? Error is a change in the data, as simple as that. For example, your data binaries are having zeros and one combinations. Assume that in a single bit, instead of 0 it is made as 1. Now your data meaning is changed, there is an error. Instead of 0, 1 is marked, so there is an error. So this is actually an error. Now what happens, data link layer, with the help of trailer, it has its own methodology to identify the errors. And then it also takes care of framing the data. And then let's move on to physical layer. Physical layer gets the frame from data link layer and adds its own header, and then it converts the entire data as a binary, combinations of zeros and ones. Now this binaries will be converted as signals, and this signals will be sent towards the next node. Next node means from A to B. So the signals will be sent through, say, cables or some wireless media as a signal. So physical layer receives the data from data link layer and adds its own header and converts the data to binary, and from binary to signals, and then signals will travel through the media. Let's see how receiver uh, will handle the data with respect to OSLA's flow. What happens, you will get the signals from media, and then the signals will be converted back as a binary values, and the data will be converted back to, I mean, it's a reverse process. From source point of view, the data travels from application layer to physical layer. When it comes to receiver, the data travels from physical layer to application layer. So then your physical layer will open its header, and it adds, I mean, it gets the content from header, and it moves the data to the data link layer. What data link layer does, it gets content from its own header and trailer, and further it reacts based on header and trailer details, and the rest of the data will move to network layer, and network layer will react based on the network header. For example, you are getting the IP address of source and destination. Network layer may check from which node the data is coming, whether the IP address is correct or not, to which node the data is received, whether the receiver IP address is matching with my address or not. Some type of mechanism will be there to work on headers. And then transport layer checks its header, further the data travels to session layer, and then session layer works on its own header, and presentation layer will get its header, and application layer will get its header. At last the data will be delivered to the end user. So ultimately, when you look into the process of data travel from one end to other end, it's as simple as that. Your data may be of, say, 10 kb, but when it travels towards the channel or a media, the size is becoming slowly, it's becoming high. When the data is there, data's I mean, application layer header is added, and then physical header, and then session header, transport header, network header, data link layers trailer and header, physical layers header. Now as the size is increasing, we cannot reduce the size by avoiding the headers. Ultimately, it is not at all possible to avoid the headers. You must have control information which helps in smooth traveling of data, smooth travel of data. So this is very much important. Yeah, I would like to add one more point about end to end communication. What is end to end communication? N, it is not end, it is n. So what I'm trying to say is, when you add a message, I mean control message in the application layer, that can only be um, read by the um, when you add a header in every layer, the header message can only be read by the header or read by the same layer of the other end. For example, when you add application header in the application layer, that can only be read by the application layer of the other end. Application layer head cannot be read by presentation layer, or presentation layer will never be useful for session layer. So this is what n to n communication. So every layer's header makes sense to the parallel layer of the other ends. If I add some technical information or control information in the network layer, that will be useful for the network layer of other ends. It can be of router 1, router 2, router n, or it can be of um, destination also. When there is a control message by a layer, it is useful for the same layer of different nodes. Let's take a scenario of data traveling from source to destination, and let's analyze how intermediate nodes also helps in data travel. Now, application layer is the one which is getting the data from the end user, say source, and the data moves to the presentation layer, and then the data moves to session layer, then transport layer, then network layer, data link layer, physical layer. So from source, slowly the data is moving towards the physical layer by adding every node, every layer's header. Let's see the bottom of the slide. You can see from source to router 1 there is one type of network, thicknet ethernet. From router 1 to router 2 there is other type of network, say GSM wireless type of network. From router 2 to destination, multi-mode fiber ethernet. In this scenario, it's a kind of kind of existing scenario. You cannot expect that there will be a similar type of networks between source and node. It is going to be a combination of different type of networks. So you have one type of internet from source to router 1, other type of network from router 1 to router 2, and the different type of networks from router 2 to router 3. So ultimately with this example we'll be understanding the role of data link layer also. So what happens now, physical layer converts the signals, and the signals through thick net ethernet network, it will reach the node router. Okay, the physical layer of router, if you see the router device, before getting into the layer structure of I mean intermediate node, let's add one more point in router. Router is a multi-homed device. A router can able to connect with multiple type of networks at the same time. Why? It is a kind of device which takes care of sending the data from one network to network. So it is designed in a way that it can able to connect with multiple networks. So your physical layer of thick ethernet interface of the router 1 gets the data. I mean, router 1 is, in this scenario, router 1 is having two interfaces. I mean, this is interface 1 and this is interface 2, and this interface 1 is connected with source. This network is actually thicknet ethernet network, and this is interface 2, and this is connected with router 2, and this is a type of GSM wireless network. If you take this router, it has again two interfaces, and this interface is connected with GSM wireless network, and this interface is connected with multi-mode fiber ethernet. So ultimately when you look at the routers, in this scenario it is a two-home router, but routers are capable of having connectivity with multiple networks. Now let's come back the flow. Now router 1 interface 1 of router 1 is receiving the signals through its physical layer from source, and then uh, it passes the data to data link layer. And what data link layer does, data link layer, with the help of its own network, underlying network technology control, it gets the signals based on that format and passes the data to network layer. Network layer checks who is the destination. As per the flow, here destination is available. Now network layer checks the destination address and decides on route. It decides on route which is to be routing decision which is to be taken in order to make the data travel towards the destination. So network layer takes the routing decision and decides in which route the data has to travel. Here in our example we have only one route, but the live scenario the routers will have multiple interfaces, multiple routes. So when you have options, the router's duty is to decide in which route the data has to travel. So network layer takes care of routing decision and decides through which route it has to go. And after the decision, when ultimately this particular router is not a destination, so always intermediate nodes are not permitted to access the top layers. The intermediate nodes depends upon the node type, only the bottom layers are permitted to access. So here router is permitted to access first three layers, I mean physical layer, data link layer and network layer. Obviously to take the routing decision you need network layer, you need IP address. So router 1 checks the IP address of network layer and decides to through which route the data has to be sent, and after decision the data will move again to data link layer. And data link, now this data link layer part, I mean this part of data link layer will work on reframing the data which is acceptable to GSM wireless networks. Okay, see, you have router is a single device, but you have two type of networks connected with network. I was explaining that this is thick ethernet internet and this is GSM wireless network. So when you have two different type of network technologies, it's the duty of data link layer to receive the data from one network in a particular framing format and reframe the data which is acceptable by GSM format. For example, what is framing? To understand the framing in a better way, let's take that you are traveling. When you travel through road, your vehicle format changes. When you travel through track, your vehicle format changes. Again, when you travel through air, your vehicle format changes. So when travel mode changes, the vehicle format changes. So considering this analogy, when travel mode is thicknet ethernet, the data format should be of one type. When travel mode is GSM wireless, the data format should be of different type. So who is playing the intermediate role? The router 1 is playing the intermediate role. So what it does, it receives the data from thick ethernet and reframes it to GSM format. Ultimately the data, the base data will never change, but the format of data, I mean you are the person who is going to travel through car or travel through train or travel through Airbus. There is no change about it. The passenger is not changing, but the vehicle format is changing. Similarly, the data will never change when it goes across different networks, but the framing format is changing, which will take care of the data link layer will take care of framing the data, and accordingly the data format is changed, and then again based on the frame the signals are changed, and I mean binary values are changed. Based on the binary values the signals are changed, and then from physical layer the data will travel through GSM wireless networks. Now the role of router 2 comes. Again router 2 through the this particular interface, router 2 will receive the signals and converts back to binary, and from binary to data. The data link layer of router 2 will get the data from GSM wireless networks in a particular format, and it converts back to a normal format, I mean a format which is applicable to network layer. It gives to network layer. Network layer will see who is the source and destination. I mean network layer of router 2 will see who is the source and destination based on its own routing algorithm or routing table. It has its own methods. When we learn about routing, we'll see about that routing decisions kind of things and all. So based on its own methodology, it decides how the data, I mean through which route the data is going to be forwarded, and then based on that decision, the network layer data, I mean the header of the network layer will be altered by the router 2, and then data link layer of router 2, again it reframes the data which is acceptable in a format of multi-mode fiber ethernet. Router 2 receives the data from GSM wireless network. So data link layer receives in that framing format. When the data is about to travel through multi-mode fiber ethernet, again data link layer takes care of converting that back to, I mean reframe that back to a format which is acceptable by multi-mode fiber ethernet. Then physical layer gets the data from, I mean frame from data link layer, converts back to binary to signals, and the signals will travel through multi-mode fiber ethernet. At last destination gets the signals from physical layer, and then to data link layer, and then network layer of destination. What it does, it just cross checks with the existing destination IP address and the self IP address. If both IP addresses are matching, the network layer will permit the data, I mean it will permit the data to travel further. Transport layer will get the data, and it will cross check with the existing process. It will verify towards I mean to which process the data should be delivered, and with the help of port number the data will be delivered to the right process, which is your Facebook chat. And the session layer ensures the session connectivity. Presentation layer works on data formatting and other stuff. Application layer at last gets the data from presentation layer and delivers the original data to the destination. So that's how it goes from application to presentation, session, transport, network, data link, physical in the source, and router 1 physical data link network layer. Again the data will come back network data link physical layer, the same process in router 2. At last in destination, physical data link network, transport, session, presentation, application. So that is how the data travels from one node to other node with the help of intermediate nodes. Let's move on to the existing protocols, how it works. I mean what all the protocols available layer wise. In the discussion of introduction to OSI layers, I was telling that the layered structure helps in protocol design. So that is how it goes. So application layer has HTTP protocol, FTP protocol, IRC protocol, and DNS protocol. Presentation layer has SSL protocol, IMAP protocol, SSH protocol, and then session layer has sockets and APIs, and transport layer has TCP, UDP, SCTP. Network layer has IP protocol, IPsec protocol, ICMP protocol, and IGMP protocol. Data link layer has Ethernet, triple P, I mean point-to-point protocol, and FDDI. Physical layer has coaxial, fiber, and wireless type of data travel modes. So this all the protocols, sample protocols. This is not complete list actually. Sample protocols which helps in doing the duties of individual layers. Let's discuss about the TCP/IP protocol suite, which is the internet model which we use nowadays for any typical network. We have OSI layer as a reference model. In OSI layer, we have a proper structure which goes in a order, say application layer, presentation layer, session layer, transport layer, network layer, data link layer, and then physical layer. TCP/IP protocol suite is an internet model which is used nowadays. This internet model or TCP/IP protocol suite is referring the OSI layer, and here the structure is having a slight change. In TCP/IP protocol suite, application layer, presentation layer, and session layer are grouped together and formed as a application layer. There is no change in the activities of the top three layers. All the top three layers are grouped and given as application layer in TCP/IP protocol suite. So hence, application layer of TCP/IP protocol suite takes care of interacting with the end user, deciding the presentation format of the data, and controlling the session. So that is what application layer in TCP/IP protocol suite does. When it comes to transport layer, there is no change between OSI layers and TCP/IP protocol suite. Transport layer is the most complex layer which is taking care of the reliable data travel between source and destination. When it comes to network layer takes care of node identification and network identification in the OSI layers, and there is no change in TCP/IP protocol suite, but there is a minor name level change. The task of the network layer, there is no change. The functions of the network layer, there is no change, but some internet models like TCP/IP protocol suite or some other networks may call this network layer as an internetworking layer also. And the underlying layers of OSI model are data link layer and physical layer. These two layers are grouped together and called as network access or network interface layer in TCP/IP protocol suite. So that is how the practical view of OSI layers. OSI layer is the reference model. TCP/IP protocol suite is the live model or internet model which is used in variety of networks and internet nowadays. Yep. Uh, I'm happy to present a small session on OSI layers. So I thank one and all who has supported. I have utilized some of the internet source images for my analogy, which is car manufacturing. I just wanted to thank also those internet resources for such a wonderful images. I thank once again for this opportunity. Thank you. Now from the analogy, what we are learning, I mean from our car manufacturing analogy, what we are learning, let's have a small analysis. Now car manufacturing is a 5-layer model where in which similar types of tasks are grouped together, which we call as a layer. So all similar type of tasks are grouped together to form a layer, and these tasks are completed one by one in a proper order, which we call it as layered structure. And there will be a proper interfaces between all the layers, group of nodes which can share resources, and end of all layers task the product is ready. Now that is how we are learning what is layered structure. So when there is a ultimate product is output, before the output we have a layered flow. One by one we are implementing it. For example, in our analogy, first we go for stamping, then we are welding, then we are painting, any type of device at last capable of at the end of inspection the product is ready. That is how layered structure works. Let's see how layered structure in networks, for example, let's take a barcode scanner. Now barcode scanner, it is connected complete architecture of networks in a simplified model. When there is a network is structured, with reference to OSI layer only, the flow of the data is formed. Now it is a device which layered structure, which is OSI layer, helps in creating or controlling set of protocols, and then or radios. Controls the network elements, receive the signals, then from the it helps in managing the network properly, and then if there is any problem in the network, to troubleshoot or debug the problem, like this structure or layered architecture helps us. Layered structure, it is not OSI layers actually, it's a part of layered structure. Now this is TCP IP protocol suite. TCP IP protocol suite is the live or receiving or both live layered structure. OSI is actually a reference model. It is the reference model given by ISO. It is not a typical model used in internet or any typical networks nowadays. It is a reference model. Now the internet model is TCP IP protocol suite. Now, when you take OSI layers, application layer, presentation layer, session layer, these three are the top layers. Now, these three layers are grouped together and given as an application layer in TCP/IP protocol. I mean, the tasks of application layer, presentation layer, and session layer, putting it together will be handled by application layer TCP/IP protocol. So it is applicable to all the views of these three layers. I mean, all the layered protocols of top three layers will be handled as a single layer in TCP protocol. So FTP, HTTP, SMTP, SNMP, and additional hardware all other presentation layers, session layers protocols are part of application layer protocol in TCP/IP protocol suite or internet model. Able to share. Next comes the transport layer. There is no change in transport layer. Let's take in TCP/IP is the short or range. The OSI reference model is used as it is as a interconnection is a standard given by the ISO. The reason is standard model given by the ISO layer, and the layer which takes care of ISO is international reliable data transfers. Workstations. It is the rest of the layers take care of other duties. Layered transport layer is the only layer which is taking care of reliability of the data travel. Reliability in the sense of flow control, what is reliability in the sense of what is the aim of connection establishment and the network to make termination procedures, what is reliability in the sense of analogy which we are sampling data loss, recovery on it works on recovery methods when a network is formed. It ensures whenever you are various mechanisms, data reliability is achieved. So as it has more tasks to be completed, there is no major changes introduced in car manufacturing suit compared to OSI layers. But the network layer again, that is also an important layer. There is no change in network layer, but instead of network layer, it can also be called as inter-networking layer.
This is
So the
a layered
functionalities
layer.
same.
One is stamping
And then
layer, two is network
data link layer,
and we can use it as a
and
layer. Four is
physical layer are grouped together and called as
installed in
network
the
access
car
or
manufacturing
network
analogy.
interface layer.
Can
Data link layer here
now
from the analogy of layered architecture. When you refer the OSI layers, the top three layers are
5-layer
model
hardware
taking care of all aspects of end user interaction. So transport layer is a process level inspection connection. Network layer is shared node level and network level connection model. Data link layer and physical layer is the short kind of hardware level interaction. I mean, controlling the media, converting the data to binary task is completed one by one layers are a part of that you are doing welding first and duty which is taken care of is not the network access level products and then assembly task. And then paint two layers are called as network access or network interface layers. So that is how the current scenario is. There must be a process order in order to implement the functionalities remain same. I repeat, when there is a no functionality change manufactured OSI layers, when there is a application layer, presentation layer, proper layer phases between the layers and called as application layer.
Whenever you are creating a product, there is
all layers, transport layer remains same, network layer remains same. So data link layer and physical layer grouped together and given a name as network access or network interface layer. Layered structure.
The process
Now let's move on to layered structure in networks. Now the layered structure in networks, basic stuff of open system interconnect OSI layers. It gives the complete OSI layer architecture, layered model. Whenever, for example, when you refer OSI layer, OSI layer is the basics of OSI network. When you form, in other words, the reference for you is OSI layers. When you know how it operates, OSI layers, you can understand anything of the complete architecture. Now this OSI layer is the basics of networks. Protocol design, all concepts in network designing network elements or deciding which network elements you wanted to use, that much important, and how the network can be managed, and if there is any problem in your network, you can start working on troubleshooting or debugging the network. And I just this layered architecture helps in different aspects. Some of the aspects are I have listed. I have used for protocol designing or controlling the protocols, networking, network elements creation or the analogy car manufacturing, and the network management in various aspects. I just wanted to thank those resources. And if there is any problem in your network, you can troubleshoot or debug using the layered structure.
Hello, this is Dr. Dinakaran M, Associate Professor, Department of IT, School of Information Technology and Engineering, VIT University, South India. I'm just going to present a session on OSI layers. Before getting into OSI layers, I'm going to give an idea about what is networks. Network is a group or collection of nodes which all these nodes can able to share resources. What is a node? Node is a kind of device. It is any device which is capable of sending or receiving or both. For example, some devices like TV, radio can able to only receive signals, whereas some devices can able to only send signals. Some devices like smartphones, computers can able to send as well as receive signals. So node is any device which can able to send as well as receive, or sometimes only send or only receive. Now what sort of resources
can be shared using networks. Resources can be like data. For example, I just wanted to share some official information to some of my friends who is sitting in different location. So I'm sending the data through network, and we can able to share devices like printers, scanners within the networks. Sometimes some networked applications we can share. Sometimes a common service will help you to share, say, web servers, websites, email access, all those stuffs. And we can also able to share resources of additional hardwares. So a overall view of network is, it is a group of nodes which can able to share resources. Next, um, we'll see what is OSI layers. Now OSI layer is abbreviated as Open System Interconnection, and it is a standard model from International Standard Organization ISO. It is derived by ISO, and it is it is a layered communication level architecture specified by ISO. Now, let's take an analogy to understand what is layered architecture. The analogy which I am going to explain you is car manufacturing company, or how car is manufactured. To manufacture a car, there are set of procedures wherein which we have to start with stamping, then welding, then painting, then assembly, and then final inspection.